Hi and welcome back. After the email addresses, usernames and image searches, we have reached section 8 called OSINT IT systems. Well, here I use the acronym OSINT as a verb because in the end, all those tools for data gathering are used to interact with those IT systems in a way. And also, as you maybe recall, I have said at the beginning of this course that this is one of my favorite sections because I'm essentially an IT guy. Here we will jump into the demonstration of the different tools you can check and learn about your company's exposure to the internet or a person's exposure. This is a critical section since almost everything we do with the technical side of open source intelligence is based on IT systems. So let's move on. Now to make a quick overview of the videos and topics in this section. First, we will talk about IP addresses and the domain name system or DNS functionalities as the foundation of almost any of our IT system investigation. I will first do a quick demystification, as I like to call it, of the two, IP and DNS, and after that show you a few of the tools with which you can potentially get answers to your IP and DNS questions during an OSINT investigation. Then we will proceed to the IoT or Internet of Things search engines. Two most popular ones are Shodan and Census. Maybe you're wondering why we didn't cover this in section 5, where we discuss search engines. The answer to that is because it's pretty simple. This is a flavor of gathering data directly from IT systems, and I believe the prerequisites for this kind of OSINT work is easier for cybersecurity professionals with an IT background. A system engineering background will be even better. And the last part of this section is dedicated to a demonstration of various OSINT tools for gathering and processing collected data. The tools are Sublister, The Harvester, ReconNG, Spiderfoot, and Maltego. Also, through a demonstration, I will show you some of them how they work, but I will definitely tell you what can you expect of each one listed here. So let's move on to our first topic of this section. In this video that is dedicated to IP addresses and DNS, I will start by demystifying these two terms. Maybe you remember that I have mentioned how for this section a prerequisite is prior knowledge about IT. In this case, for you to be familiar with the IP addresses and the domain name systems. What is it and how it works? I will start with the IP addresses. Actually, the IPv4 addresses. You're probably already aware that an IP address is a set of numbers with the purpose of identifying a device on a computer network. And in our case, we will speak of the internet as a network, as a big computer network, since our main resources are found on the internet for our open source investigations. IP addresses are all over the place. Your computer right now has an IP address, probably a private one, and that brings us to our second bullet. The two major groups or types of IP addresses, private and public. This is probably one of the main things you should be aware of concerning the IP addresses. The private ones that are covered in the RFC 1918, just Google it, are just that, private, not exposed to the internet directly. Rather, they're in your corporate network or simply on your home network with your home router. Probably your computer right now is sitting on a private address. That address could come from three blocks or classes as they call them, ABC. 192.168.0.0, then 172.16.0.0, and a 10 class 10.0.0.0. For an example, my computer IP address is 192.168.0.12 with a subnet of 255.255.255.0 or the /24 subnet. The public IP address, on the other hand, is a little bit different. All the other IPv4 addresses belong to the public space and they are routed and used in the public realm of the internet. When you ping google.com, you will ping the public IP address of that server from your private or home network. Now I won't go into details and the inner workings how IPs are used and how all the other technologies are involved, like the network address translation or NAT. Rather, we will now focus how our IP address is used in our OSINT investigations. Now that we have demystified IP addresses, at least a little bit, I would like to show you how our IP addresses are used in the location context, which is very important in open source intelligence. As you know, IP addresses are often obtained from all kinds of resources throughout the internet, email messages, social network posts, through scanning techniques, and so forth. There are a few great resources with which you can learn about the location of the IP address, and by that, the location of your target. And I would like to show them to you right now. Here we are in our browser. First is the iplocation.net service. This is a free website that gives the IP address results. This is probably something I use all the time, and it is pretty much straightforward. When you visit the site, immediately you get the information about your IP address through the browser you use. As you can see, all kinds of information is here. My location, host name with the ISP name. I use a VPN, and don't forget to use that when you do your investigations. Then the platform, browser details, even the screen size. And now when we have an IP address that we want to look at, we will type in the IP location finder box. I will use 8.8.8.8, which is a public IP address of the Google DNS server. And just as a side note, in networking, pinging the 8.8.8.8 address is one of the methods to confirm do you have IP connectivity to the internet. So, and press IP lookup. Here we don't get that comprehensive report like on our IP address previously, but a great feature is that we get the geolocation data from other services like ipinfo.io. That is a good cross-reference to double or triple check immediately, but I like to double check the IP's info going to the other servers separately. Next on our location tools list is the ipfingerprints.com, so let's go there. I like this service because of its good use of a map. Besides your approximate location, when you type in the IP address, you also get the map-based results. I will use the same Google IP address and press discover. As you can see, the map. And last on the list is the ipinfo.io, which is my personal favorite. It is not completely free, but it gave me best results when I have done my investigations. Actually, I use their API, and currently through the usage of their API, you can make about Actually, I use their API, and currently through the usage of their API, you can make 50,000 requests per month, which is usually more than enough for at least my needs. I encourage you to check the developer's guide on the site. Now the DNS or the domain name system part of the OSINT investigation. Just to do a quick demystification of the DNS. DNS or the domain name system is, as the Wikipedia states, a hierarchical and decentralized naming system for computers, services, or other resources connected to the internet or a private network. It associates various information with domain names assigned to each of the participating entities. Basically, it is a phone book of the internet. When you access a website with your web browser, you type in the name of the site, like google.com. But what it really means to the computer? Oh, google.com, you say? That's 172.217.16.174 located on port 443, and you should look there for it. You can also try and put the IP address in the address bar of your web browser and see what happens. You will also visit google.com by entering the correct IP address in your address bar. But it is a lot easier to remember the domain google.com rather than a bunch of numbers. Just like a phone book, when you access your phone book, you usually don't look for a number, rather a person's name which is assigned to a number. Okay, now that we demystified DNS a little bit, I want to show you a useful online tool for DNS investigations in the OSINT context. The tool is called ViewDNS and it is located on the viewdns.info address. This tool is useful once you have identified an IP address of your target. Once again, let's go to our secure browser and type in the address viewdns.info. And as you can see, actually there are a lot of tools integrated in this framework. And now I want to show you some of them. As I have mentioned, you have your IP of interest and you can start checking its DNS information. A first step would be to use the reverse IP lookup. This tool will display all the sites that are hosted on a given server. If for some reason you are looking at a website that potentially resides on a shared hosting. Here is my example, the itino.net domain. Type itino.net in the domain/IP box and press go. As you can see, there are over 330 domains hosted on this server, so this is most definitely a shared hosting type of server. We can also check the WHOIS data, and that kind of research can reveal all kinds of information, because sometimes WHOIS includes phone numbers and direct email addresses. Also, location is very interesting. Just like we did it before in the previous section with the IP addresses, just type in the target's IP and press go. I will type 662.6.25.26 to check where is it. It's in the States, Florida actually. Now another cool feature is to check, are there any open ports? Actually, for the common ports that may be open. Let's do it again with the same IP. As you can see from a brief demonstration, a lot of information can be revealed and extracted from a tool like this. ViewDNS also has an API, and its API plans are intended to be used in a more intensive research. Check it out if it fits your needs. And now, in the next video, we will cover an interesting search engine approach, almost Google-like, but dedicated to devices and computer networks. The next video is called IoT Search Engines, so see you there. Hi and welcome back. After our basic IP address and DNS research in the previous video, this video is dedicated to the research of devices that are connected to the internet, or better to say exposed to the internet from around the world. Welcome to the world of IoT search engines. There are two most popular online resources for that, Shodan.io and Census.io. They are very similar, but also very different when using them. I'll show you both of them, how they look, and some basic features and usage scenarios. First is Shodan.io, and you can find it on that address, Shodan, SHODAN.io. Shodan is also known as the Google for IoT devices, actually Internet of Things. Just to demystify the term IoT, In the broadest sense, the term IoT encompasses everything connected to the internet, from smart toasters over routers to fitness collars for dogs. With a tool or a search engine like Shodan, you have the ability to check the exposure of those connected devices. How do they look like when facing the internet? And by that, you can do an exposure check of a system/device and also see if they have some known or unknown vulnerabilities. As always, there are two sides of this coin, the good and the bad. The good guys, like network security professionals, use this side to identify potential holes and vulnerabilities of their systems. And the bad guys, the black hat hackers, use it to illegally access networks and alter devices. Allow me to show you how it looks like. Again, we will go with our browser to the shodan.io address. As you can see, this is the search engine for the Internet of Things. There is a free option without registration and an option with registration. The main difference is that without registration you cannot use any of the advanced search operators. The best option is to pay for the access and take advantage of Shodan's full search capabilities. Now I will just search for one IP address without registration. In the search box I will put down A.A.8 and press search. As you can see, I have received some data about this address. I know its hostname, dns.google. I know it is located in the States and port 53, which is the DNS port, is open, as it should be. Now I will try to use some search operator, like country column HR, and oops, an error. We need an account. Now I will log in to show it how it looks like. Now I'm logged in with my account and I will again use the country operator, country column HR, that is the short code for my country, Croatia, and search. As you can see, we got over 175,000 results. 175,000 results. Now I will add a port to my search. So space port column 53. Now we got almost 9,000 results. You can really narrow it down and find some pretty interesting things. Just use a public address space of a company and you can usually find all kinds of things exposed. And that happens only if the target company does not maintain their security posture. There is also an API of Shodan that can be integrated with the reconnaissance tools, different reconnaissance tools that we will mention in the next video. And by that you can use Shodan capabilities at their full capacity in other tools. Now back to our slide. I will just tell you a few things about Census.io. Census is also a search engine that enables researchers to ask questions about the hosts and networks that comprise the internet. It is known in the security community as the academic-like search engine since it is an interactive project from the University of Michigan, USA. The backbone is ZMAP and it is also web-based, has an API and drives on the SQL database. Census performs weekly scans of the IPv4 internet address space and all the data is transparently stored in the accessible database. You should really check it out. Okay, now, hope you get a good understanding how to approach the exposure part of devices and computer networks. And now we are going to cover some of the most popular tools for reconnaissance of IT systems. So see you in the next video. Hi everyone, and welcome to the last video of our section 8 that is devoted to open source intelligence and IT systems exposure to the internet. I'm sorry, but I have to repeat a fact again. Actually, a statistic from section 2 that states how much time goes out to the reconnaissance or OSINT phase of the cyber attack. It is very well over 70%. Maybe that is a low number, because some security experts talk about statistics well over 80 and 90%. There is a cool quote that goes out to Mr. Zach Whitaker from TechCrunch. It goes, "If you leave something on the internet long enough, someone will hack it." Remember this quote when you encounter something through previously mentioned Shodan or Census tools. Here are a few of the most popular tools for reconnaissance in the context of OSINT and IT systems. First on the list is a tool called Sublister, with a 3. This is a Python tool designated to enumerate subdomains of websites. And now I would like to show you how it looks like. Hi, here we are in the terminal session of our host machine. Maybe you remember we configured from the management perspective to access our virtual machine from our host machine via SSH protocol. So let's go and do that. Here's my terminal app, and I will SSH into the Ubuntu virtual machine that is running on my VirtualBox app. To access, SSH space -p because we have a custom port, username, and the local host because the ports are forwarded to VirtualBox. Type in the password. Okay, we are in. Let's clear the screen. First, let's check the Python version on the system. This can be easily done by typing Python and then pressing Tab key to display the versions installed. We see we have Python 3, but if you need the exact version, simply type Python 3 space minus capital V and see the exact version. Now we will also use the Git repository to download and install Sublister, which you can access on github.com/aboul3la/sublister, spelled SUBLIST3R. But on a clean Ubuntu install, Git is not present. So first we need to add it to our system. To install Git with its default packages, type sudo space apt space install git. Type in the password, sudo password. This is actually a common error when you use the virtual machine. So we're going to just clear that up and get back here. Okay, we killed the process that was hanging and preventing us from installing Git. Now let's do it again. Sudo space, press space, apt space install git. Yes, we want to continue. Okay, now we are ready to install Sublister. Actually clone it from the Git repository. Again, I will clear the screen. So type git space clone space and the link from the GitHub page. It's already done. Great. And go to the newly created Sublister folder. Let's see where it is. As you can see, it's here. Okay, after that, we need to install all the dependencies to run Sublister. The easiest way is to use the pip command as it is displayed on the GitHub web page of the Sublister tool. But we need to install pip first, pip. Pip is a tool for installing Python packages. With pip, you can search, download, and install packages from Python package index and other package indexes. With pip, we will be able to install all the prerequisites for the Sublister usage. To install it, simply type sudo. The first stage is to update the system. Sudo apt update. And wait for the update to finish. Okay. After that, type sudo space apt space install python 3 hyphen pip and enter. Yes, we want to continue. After pip has been installed, we are ready to install our dependencies. Let's clear our screen. Now, as stated in the official Sublister GitHub webpage, to install dependencies, we have to type sudo space pip 3 space install space -r space requirements .txt and enter. Okay, and finally we are ready to run our sublister. First we will check the help section of the tool. Let's navigate, let's display the folder contents. Okay, here it is. To get to the help section, type Python 3 space sublister dot py -h. And here are the arguments, the options. Let's have a better look. Okay. Now we will enumerate our target domain. I will use my own, itino.net, for itino. Okay. Type to run the command, to run the tool actually. Python 3 space sublister dot py -d. -d means that the domain name will follow after that. And that is our target domain, itino.net space minus or -o. O saves the results to a text file, and I will call it the file itino. So to recap the command, it's Python 3 space sublister.py space -d space itino.net space -o space itino. And enter. Wait for the sublister to do his thing. And voila. Again, let's clear our screen. Check the contents of the folder. As you can see, here it is, itino, the file with the results. I will simply display it on the terminal with the cat command. As you can see, these are the subdomains that sublister found from different sources over the internet. A cool feature of sublister is that it can be used as a module in your Python scripts. So if you know how to code in Python, you can use this module as a cool additional thing to have in your program. Back to our reconnaissance tools slide. Next is a tool called the Harvester. It kind of sounds like a vintage horror movie title, but it's really cool. The Harvester is great, a great tool, and its name suggests that it harvests, gathers emails, subdomains, hosts, PGP key servers, and many more data from different public sources like search engines. I will do a quick demonstration of the tool. Again, in our terminal of our Awesome machine, first we have to install, of course, the Harvester. There is a great installation guide on the GitHub page. The link to it, as you can see, is github.com/laramie/theharvester/wiki/installation. You can actually Google it to be for sure. First, we will clone the Harvester from Git. As before, you have to have Git in your Ubuntu so you can use it. We did it already, so we have it. Type git clone and the link to the tool, https://github.com/laramies/the harvester with the capital letter H, and enter. After the cloning has been done, go to the newly created directory. And see the contents. Here it is. After that, as before, we need to install all the dependencies to run Harvester. Also, the easiest way is to use the pip command. And we already installed pip in the previous video, so we have it. So now we have to install the dependencies, we have to position ourselves in the Harvester directory, which we already did, and type python 3 space -m space pip space install space -r space requirements /base.txt. Let's clear our screen after Harvester has done his thing with the requirements. Okay. As always, my first suggestion is to go to the help section so you can learn how to even use the tool. So type python 3 space the harvester.py space -h. Here's the list of arguments. Now let's do a basic harvesting. And as before, I will use my domain as the target. Type python 3 space the harvester.py space -d for the domain name itino.net space -l, which stands, that's the limit of the number -l limits the number of search results. The default is 500. We will put up 300 space -b. As you can see, B is the sources from which the data will be gathered. We will use all. -b space all space -f which means save it to a file name. Be aware that the outputs can be generated both in HTML and XML, and that is very useful when you need to incorporate the Harvester results in your OSINT report. So -f space, let's call it test1. Okay, to recap the command, python 3 space the harvester.py space -d space itino.net space -L space 300 space -B space all space -F space test1 as the file name, and press enter. Disregard the missing API keys, and I will show you in a moment where are they stored and where you can type them in if you have them. By using the API keys, you can utilize other modules like Shodan and get Shodan results inside your Harvester tool results. As you can see, the results are immediately displayed on the screen on the terminal. Okay, it's done. I promised you to show the file with the API keys. The file name is api-keys.yaml. I'm going to show you via the cat command. As you can see here, you can type in the API keys. One of my main APIs that I use with any of the tools like this is the Shodan API key. The beauty of the Harvester is that it has passive and active modules. That means just that. A passive gathers information from the internet sources without touching the target, like the search engines, Google, Baidu, Shodan, Yahoo, and so forth. While the active modules, like DNS brute force, they interacts a lot with the target and leaves a good digital footprint, so be careful with it, and of course be aware of it. Now back to our reconnaissance tools slide again. Now I'm just going to tell you about some additional tools. Actually, these tools are probably the most popular ones that there are in the OSINT gathering context. Some of them are free and some of them cost a pretty penny. The first is ReconNG. This is a web reconnaissance framework, also written in Python. It is consisted of independent modules, database interactions, it has an interactive help, different built-in functions and commands. This is a really powerful environment in which OSINT research can be conducted quickly and thoroughly. I really encourage you to check it out. After that, I have to mention Spiderfoot. Spiderfoot is also a great Python tool and a reconnaissance tool. It automatically queries over 100 public data sources to gather intelligence on IP addresses, domain names, email addresses, names, and many more. This is a web-based tool that visualizes your results. Do not forget that although some of the tools do the same things, the results can be very different, so always cross-reference and double-check things. And lastly, I have to mention Maltego from Praterma. Maltego is a very cool data mining tool that mines a variety of open source data resources and uses that data to create graphs for analyzing connections. What basically happens in Maltego is the platform itself does not only extract data, but also visualizes that data in a format which is easy to understand as well as to analyze it. You could easily spend hours, actually days and weeks, on each of the tools mentioned. Maltego has its own training sessions, and that is something to consider if you really have the need for it. Okay, now, we went through some of the popular tools, where I even showed you how to install and do a basic OSINT search with them. And now we are prepared to move on to almost our last section of this course, and that section is called Data Breaches and Leaks. So see you in the next video. Hi everyone, and welcome to the section 9 of our OSINT journey together. The title Data Breaches and Leaks sounds kind of scary because the moment you see a title data breach or a data leak, it is linked to some bad thing that has happened. And most of the times that is true. But we can be better and smarter about that. This section has a few additional things that we need to consider, and I will show you what are those things by covering them in this section. Now let's do a quick section overview. First we will go cover the internet structure. Then go over the different online resources for checking your information against breached data and different leaks that are out there. Then we will go over the most popular online breach data and leak resources that are available online. And lastly, as a bonus, we will go through Tor as a free service for anonymous communication, and there we will go through the demystification of the term and the service. Now let's head on to the internet structure as our first stop. This is very important because in this way you will visualize yourself where data actually is. I will show you an illustration of the internet structure that you have probably seen before. And believe me, this is a pretty popular and good analogy of it. Here it is. The internet structure, the iceberg analogy. This is pretty cool and I think it really points to its merit. People often confuse the terms internet, www, deep web and dark web. Actually, the term deep web and dark web are often wrongly used. Those terms are related, but they mean different things. So I would like to demystify them for you now. If we look at the internet, we can say it is a physical connection that is consisted of all the computers around the world. And we can look at it as the hardware layer or a machine, one big machine. On top of that hardware layer, there is the software layer, which we will call the www or the surface internet. This is where we go to different websites and search engines like Google, DuckDuckGo, Yahoo. We enjoy Reddit, YouTube, learn stuff, and so forth. It basically means that www is the type of software that runs on top of the internet, the hardware. And all of that makes about 4% of total pages available. This sounds wrong, doesn't it? Well, I also thought that to myself when I first heard it, but when you hear what the deep web is, it will all make sense. The deep web that is below the surface on the picture is basically all the content that the search engines are not allowed to see. Those areas are usually password protected and search engines can go in. As an example, take Facebook. How many content is password protected there? A lot. All the profiles and pages, pictures, videos, comments, everything, right? The deep web also consists of all the financial records, medical documents, reports, legal documents, and many more. When we get to the dark web, which is on the bottom of the picture, with all the scary things from almost every story you hear, we change the software that runs on top of the internet. It is not www anymore, rather onion pages, accessible via specialized browsers like Tor. Dark web is usually linked to criminal activity and illegal marketplaces, but both of them serve as privacy preservers, and that is the thing that is pretty discussable here. Just a fun fact, did you know that Facebook has its version on an Onion site that is accessible with previously mentioned specialized browser Tor? I won't go that technical into it, but I encourage you to learn about it since you will probably use it in your tool arsenal for OSINT investigations. Actually, in the last part of this section, I will try to demystify Tor as a bonus for you so you are better prepared for your further OSINT research activities. Okay, now hope you get a good understanding how does the internet look like, and now we are going to jump on some online resources where all that online breach data can be found. So see you in the next video. Hi and welcome back. Now we are going to cover some of the most popular online breach data and leaks resources. Throughout this course, I have mentioned various websites that allow queries of your targeted data against breached and leaked content. We will now revisit those mentioned sources with some additional ones. But first, I would like to do a demystification of these two terms, breached and leaked data. Actually, rather to tell you the difference between a data breach and a data leak. That data breach is a deliberate criminal intrusion where the end result is the loss of data, or the data is acquired by the criminals or hackers in this context. While leaks are usually unintentional public exposure of data. A typical example of a data leak is when you hear the news like a misconfigured server happened and millions of customers' personal records were exposed. Okay, now that we know the difference between those two, we can browse through a few resources. First, and the most popular one out there, is the site haveibeenpwned.com. It's spelled haveibeenpwned.com. This online resource or website allows you to search by simply entering an email address. The result displayed is a list of breaches your email address was involved in, or pawned as they say. And the second one is one of my favorite, and that is leakpeek.com. It's spelled leakpeek.com. Site leakpeek.com allows you to search by entering an email, username, even a password of your interest. When a compromised account is found in a breach, and if that account has a password attached to itself, LeakPeek will show the first few characters of that password. The rest of the password characters are hidden with little star signs, so there is also an API paid version. I will not recommend on paying for you to access this data because it was probably acquired by hackers and it is a gray area in the legal and ethical sense of at best. But that is my personal opinion and a suggestion for you. After LeakPeek, I will mention intelx.io or IntelligenceX as the name suggests. I haven't had much experience with this site, but it's very popular. But from what I have investigated on it, it is worth mentioning and good for you to know about it. After IntelX, I will mention ghostproject.fr. This is one of the sites when I first visited was feeling I got a feeling I was doing something really shady, and the reason to that is that they clearly state that their database of 41 gigabytes dump was found on an underground community forum in December 2017. According to them, they have 1.4 billion clear text credentials discovered in one single database. There is also a paid option to unlock all the passwords, so please be careful with that. Then, this is one of the services I have mentioned earlier in the course, and for some reason I had better luck with it. It's called thehashed.com. They also have their own breach database from which they give you the results, if available of course. A cool thing is that you can utilize regex in the searches. Almost like you can search for anything here, so I really encourage you to first Google regex and learn about it, how to use it in a search context. And now for a seize the domain example. WeLeakInfo.com. This site was a good resource that the OSINT community used. Go and try to visit it and you will see. I have put this on the list just for you to understand the seriousness of this kind of sites and data you are after. And the two last bullets are just another suggestions. A search engine approach with dorking and the advanced search operators. On a more shady-like approach with the darknet access, but this is just for you to be aware of. And now, the bonus I have promised you earlier, Tor. I think we have to mention this concept or framework because it is the essential part of all the things we have discussed in this section, from the internet structure to the breached data resources. Hello everyone, and welcome to the bonus section of the course called Tor. And actually, the last video of this course, okay, I won't congratulate you just yet, but believe me when I say that we are near the end of our little OSINT journey. So let's go on and demystify Tor. What is Tor? Okay, so I find the Wikipedia definition may be most relevant. Tor is free and open source software for enabling anonymous communication. This is one of the best methods to preserve your online privacy and to protect your online activities from the eyes of advertisers, governments, criminals like stalkers, and so forth. Then why is there a picture of an onion here? And no, this is not a fraudulent course to somehow increase the sales of onions, rather to provide you with an explanation because the name derives from the original project name, the Onion Router. You know how the more you peel an onion, the more it smells. Well, here's the analogy. Tor tries to anonymize your online activity by encasing your traffic in multiple layers of encryption, then sending it a number of nodes that peel back those layers one at a time, and hence the onion nickname. When you start going through Tor, you will surely want to answer a question how to access the dark web. Dark web resides on the special top-level domain for anonymous onion service or hidden service with its name .onion. Such addresses are not actual DNS names, and the .onion TLD is not in the internet DNS root. But with the appropriate proxy software installed, internet programs such as web browsers can access sites with the .onion addresses by sending the request through the Tor network. Now I want to show you how does Tor work with a simple topology of a Tor communication process. So check it out. We, the users, or Alice or Joe or whatever the name of the end user on the left is, picks a random path to a destination server when Alice simply wants to access a website. So Alice sends a packet and each node decrypts only enough information to know where to send it next in the Tor network. So none of the nodes knows both your identity and the identity of a website or a server that you wish to reach, or Alice. As you can see, the traffic goes all around encrypted without a possibility for anyone to know where you are going. Although this sounds almost bulletproof, it isn't. And that is one of the disadvantages of Tor. At some point, your data has to leave the Tor network to get to your first intended destination. And that last point of exit is called the exit node. And that's the very last node your data travels through. At that moment, between the last node and the destination, your data isn't necessarily encrypted. And that is one of the disadvantages when using Tor. Another disadvantage is speed, so be patient when using it. Downloading and simple fast browsing will take some time, so my suggestion is don't use it for downloads or streaming high quality videos and other things. Having said that, it is still very difficult to trace someone over the Tor network, and the potential to read through your traffic has the operator of the exit node and whatever site that you are connecting to. Okay, now you are probably asking yourself how to access Tor, the Tor network, or even browse the Tor sites. A very simple way is the Tor browser that is provided by the Tor Foundation for free. You can find it on the torproject.org/downloads webpage, and you have a possibility to use it in almost all the flavors of any operating system. This is a modified version of Firefox browser that, among other things, tries to use the most secure connections when browsing. Again, remember HTTPS everywhere plugin we talked about when preparing our OSINT environment. Please be aware that any app or a plugin probably won't work when using a Tor network by default, and then there is a good possibility that your identity could get leaked through an IP address or some other personal information by using those unprotected plugins. Also, please check out the Tor documentation tab on the Tor project website, because there is a plethora of information about it there. Tor may not be perfect, but it is a good first step to protecting your privacy, and is a good tool as well as for the good guys like researchers, cyber defense professionals, activists, privacy-aware persons, and unfortunately for the bad guys like cyber criminals, stalkers, and other bad people. Go on and try it out. Actually, try accessing regular websites and some flavors of What's My IP service, so you can see what IP address you get when using the Tor browser. The IP should change randomly every few moments. And now, why did I tell all this about Tor or explain anything about it? About the internet structure, the deep web, dark web, and all that stuff? Because surely at some point in your OSINT investigations you will go looking for some data and information on those services. Remember, I said that the visible internet makes up only about 4% of the whole internet structure. That's a really small number. I hope you got a little bit familiar with the data breach and leaks concept, but also with the internet structure and the usage of the Tor software. In the next section, actually a video, is dedicated to our conclusion of this course. So in the next video, I will give you my final thoughts with some suggestions where to go next with your OSINT studies. See you there. Hi everyone. I won't go through a pathetic rant how this is my last high in this course. But all good things must come to an end. Actually, I don't even agree with this saying. And I just want to tell you, I really hope you understood what is open source intelligence all about. Because of the fast changing pace of technologies and methods used in OSINT, probably most of the techniques here that we have talked about will become outdated in the near future. But the key is, you understand that you understood the OSINT way of thinking. I really believe you can learn to be more analytical and efficient in any research you do. Because I can tell you from my experience, or an example, I'm not an analytical, mathematical person. Rather, I really enjoy reading, playing the guitar, singing, meeting people, and that is one of the reasons people do not believe me that I'm essentially an IT guy. But that is out of the scope of this course. Okay, just kidding there. Now, I would like to share a quote that I share in any of my OSINT trainings that I conduct. It goes out to the historian Mr. Yuval Noah Harari. He wrote, quote, "In a world deluged by irrelevant information, clarity is power." End quote. I think that this quote represents what is OSINT all about. Extract the data, put it in the right context, and finally make decisions based on that information. Open source intelligence could easily leave you feel scary and insecure, because when you look how much information could you find online only about yourself throughout this course, you could easily get overwhelmed. And remember that each of these investigation techniques could be used against you or your organization, so take OSINT as a two-way street. And as you know, technology tends to change at warp speed actually, but humans don't. So that is also a thing to consider, because user habits are not that easy to change regardless of the technology that is being used. And that comes as a handy feature for us OSINT guys to solve our investigations. Regarding the learning part of OSINT, the further learning part of OSINT, I want to give you a few advices. First would be network with people, or if you're not that kind of a person, learn to be better at it. It will help you. Try every tool or a technique that you come across. Actually, a better advice would be if you read somewhere something about a new OSINT method or a technique, don't just go through it like web browsing. Rather go on and try it for yourself, because from my experience, there are a lot of tools out there, and just knowing about them is not enough. You have to try them out and see are they even any good for your investigations of any kind. Now, if you're wondering where to look for additional resources about open source intelligence, you just sit tight, because there will be more content around it on EC Council's Code Red. But in the meantime, I would suggest for you to always stay updated with the current events in cybersecurity or the OSINT community by following different sites, podcasts, people Twitter profiles, and so forth. One of my favorite podcasts comes from Mr. Michael Bazels on inteltechniques.com. The podcast is called The Privacy, Security, and OSINT. Or you could try, there's a plethora of OSINT resources on OSINT Curious. That's OSINT curio.us, like OSINT Curious. They have a ton of cool tips and tricks updated almost daily. I'm going to be very honest now. The way that I get my OSINT and cyber news daily on a daily basis is through a simple news feed. I use RSS because I like getting a more press-cut perspective of information and news, and also it's very useful for your privacy side. So check that approach. Be free to contact me for any questions, suggestions, comments, or just for a simple chat about OSINT or cyber stuff. I believe you have enough knowledge now to learn how to get in touch with me. Okay, just kidding there. Once again, my name is Tino Šokić, and I would like to thank you for watching and learning about open source intelligence presented by EC Council. Also, do not forget to take the course assessments to check your understandings of the course. And as always, I would really recommend for you to check out some other fantastic content here on Code Red. I hope you had fun, and as they said on the Seinfeld show, stay out of the deep end. Bye everyone.
Hello guys, and welcome to the first chapter of this course. Wi-Fi adapters are used for connecting your device to the internet. Most laptops, tablets, and mobile phones have a built-in Wi-Fi card. In a wireless environment, data is transferred from the device to the internet in the form of packets by sending a request for a packet to the router. The router fetches the requested packet from the internet, and once it obtains the web page, it sends the information back to your device in the form of packets, of course, thereby controlling all the traffic going to connected devices. Monitor mode allows you to read all the packets of data, even if they are not sent through this mode, and controls the traffic received on wireless-only network. Monitor mode is able to capture all the packets, which are not only directed to your device, but also to other devices connected to this network. For an ethical hacker, monitor mode is used to capture all relevant data packets to check whether the router is vulnerable. It can also be used to check whether the network is vulnerable to any attacks. So monitor mode provides all the crucial information on every device and can also be used for observing large volumes of network traffic. This video will provide an overview of monitor mode in Linux. To follow along, you will need a computer capable of running Wireshark and putting your Wi-Fi network adapter into monitor mode. You can do so on Kali Linux or any Debian-based Linux computer, as well as in a virtual machine on a Mac OS or Windows device. You will also need an external Wi-Fi network adapter that's capable of being put into monitor mode. If you don't have or if you don't want to use your default built-in Wi-Fi network adapter. To get started, plug in your wireless network adapter to your Kali or Debian-based system, then identify its name by running the command ifconfig in a terminal window. So as you can see, since I typed ifconfig, I am presented with information about all the network interfaces that are attached to my computer. For the wireless network adapters, I have two. The default built-in one that is called WLAN 0 and the external Wi-Fi adapter that I'm going to use for this video that is called WLAN 1. Now you should see your card named something similar like WLAN 1 or WLAN 0, and if it doesn't automatically appear if you type ifconfig, then you can type IP space A to see if it's attached but not yet up. So if it's not yet up but attached, you can run the command ifconfig space the name of your wireless network interface and then space up to bring your card up. Since you typed this command, now it should appear and be visible in your terminal. A note here, some systems will use a different name for the Wi-Fi interface like WLP5S0 and so on instead of the default WLAN 0. That is fine, just replace any command that has WLAN 1 in my case that I'm going to use with whatever your system calls the Wi-Fi interface. So there is a couple of ways to set your wireless network adapter into monitor mode. The first is just check our wireless network interfaces in our computer by typing iwconfig. And we are presented with all the information about our wireless network interfaces. And as you can see, both of our wireless network interfaces are in managed mode. As I said, I am going to use WLAN 1 and set it into monitor mode. So we can just go ahead and first bring the interface down by typing ifconfig WLAN 1 down. After that, we are going to use the iwconfig command to set our wireless network interface into monitor mode. Yes, sometimes with the first command, when you're trying to bring your interface down, it doesn't fully comply. So let's just do it one more time. You see now it took some time until our next line appears. So we can just go ahead and set it on monitor mode now. And now we don't have any errors or warnings. Now it's fine. And the next step is that we have to bring our interface up again so it can be fully functional or on monitor mode by typing ifconfig WLAN 1 up. Since you hit enter, your network interface should be up and running and in monitor mode. So let's just check this one by typing iwconfig. And now you can see that our WLAN 1 wireless network interface is being set to monitor mode, and you can see it here. To return the interface to normal managed mode, you can follow the same procedure. ifconfig WLAN down, running twice in some cases, like in my case. Does it go with the first command, first time typing the command, Now we have to use iwconfig, like we said earlier. WLAN1 and then mode space managed. Then we can bring our interface back up again to our normal, to the normal managed mode. Let's just check if that's the case. And we can see that our WLAN1 is back to managed mode. So there is another command that we can use, which is the rmon-ng. So if you don't have that in your Linux distribution, then just go ahead and install it first before we continue. So if you don't have it, you can just go ahead and type apt-get space install space rcrack-ng. Now you can just go ahead and press enter, and this will install the rmon-ng. The next thing we can do is we need to use rmon-ng in order to check for any processes that will interfere with our network interface being set to monitor mode. So this can be done with the following command. rmon-ng space check. You hit enter, and then we are presented with the 4 processes that they are running in a current Linux machine that can cause trouble. So as has been indicated here, we need to kill them before putting the card into monitor mode, because this will sometimes put our interface back into managed mode, and we don't want that since we are capturing some packets. So you can just go ahead and type rmon-ng check kill and then the process ID, and you can kill them all first, and then we can continue setting our wireless network interface into monitor mode. So now that we killed all the processes that could cause trouble in our monitor mode, let's just put the interface into monitor mode by typing rmon-ng start WLAN1. So you can see now here that our WLAN1 interface is being set to monitor mode. As you can see, it's enabled here, and now we can start checking the traffic. So now, as you can see, that the card changed the name to WLAN1 Mon, since it's on monitor mode, and we can start listening on Wi-Fi traffic by running the command aerodub-ng space WLAN1 Mon, since our WLAN1 is on monitor mode now. So we can just go ahead and hit enter. And now, as you can see, we see a list of nearby Wi-Fi networks that we can target. We also have the channels here. So let's just go ahead, and this is our channel and Wi-Fi, and let's just go ahead and stop the capture. And now we stop the capture, and we can determine the channel and the network we want to track. As we said, we are going to track our domestic network on this channel, so we can just go ahead and type aerodub -G space WLAN1mon space -C for the channel. So we're going to use the flag -S to start listening to that channel. So as we said, we are going to choose channel 11, and then we can go ahead and press enter. This will showcase that the aerodump -G runs on channel 11, and now it's time to start the Wireshark. So we have open Wireshark here, and we can see the WLAN1mon. We can select this monitor mode interface that we have just set up, and we can just go ahead here and start capturing the packets. As you can see, we can actually see all the traffic going through our wireless network. Normally, you should see a lot of packets being intercepted by Wireshark. And whenever you feel ready, you can go ahead and stop the capture, and you can save this capture with the name of your desire. So I hope you have enjoyed this video, and now you can just go ahead and click on the next video where you're going to learn how to filter by port and IP on Wireshark.
Hello guys, and welcome to the second video of this chapter. While debugging a particular problem, sometimes you may have to analyze the protocol traffic going out, coming into your machine. Wireshark is one of the best tools used for this purpose. So in this video, we will explore that possibility with Wireshark and learn how to apply display filters so we can filter out the unwanted results from the network capture and focus on the desired ones. Once you have opened Wireshark, you have to first select a particular network interface of your machine and just start capturing the traffic that you would like to explore. For the purpose of this tutorial, I have already captured and saved some network traffic that we are going to use in order to understand how to apply display filters. So we are going to use this one. So as you can see, I have loaded the pickup file that I saved in particular for this tutorial so we can explore the filters. So let's just go ahead and start with the first one. So the first one we are going to explore is the source IP filter. So a source IP filter can be applied to restrict the packet view in Wireshark to only those packets that have a source IP as mentioned in the filter. So you can just go ahead and apply let's say that we would like to see all the results with this source IP of this IP. So you can just go ahead on the display filter and type IP dot src, and then equals and then you type the IP address that you would like to focus the results upon, which is the source IP. In this case, we selected this IP, so let's just go ahead and type this IP and hit enter. And from the moment that you hit enter, the filter categorizes all the results by the source IP that we type. So you can see, if you just scroll down, you will see that the source IP is the one that we selected, and you can just go ahead and explore, investigate the traffic coming out of this IP. So the second filter that we are going to explore is the destination IP filter. So the destination IP filter can be applied to restrict the packet view to only those packets that have a specific destination IP that we would like to check the traffic from. So in the same manner, you can go to the display filter section of Wireshark and apply and write in this occasion IP.dst equals, and then you type the destination IP that you would like to see the traffic going to. Let's say in this occasion we are going to choose this IP and go ahead and just apply enter, and then you will see that all the results have been categorized by the destination IP that we wrote on the display filter. So in the same manner as before, you can just go ahead and explore all the IP and explore all the traffic that is destined to that IP address. Also, it is very easy to apply filter for a particular protocol that you would like to see traffic. So you just go ahead in the display filter and type the name of that protocol that you would like to see the traffic for. So let's just go ahead and type HTTP and see the traffic, only the HTTP traffic that we have in this network capture file. So as you can see, all the results have been filtered out by the HTTP protocol. So we see all traffic from all sorts of source IPs and destination IPs using the HTTP protocol. You can also use conditions in the filter. Using the OR condition in the filter helps filtering the packet that match either one or the other condition that we are going to set. So let's say that there may arise a requirement to see packets that either have protocol, let's say HTTP or ARP. In that case, you cannot apply separate filters. So it exists this OR condition filter that we are going to see now, how we are going to write, and it expresses the OR condition to display the results matching one or both the conditions. That is also possible. So let's just go ahead and see an example and try. Let's say that we would like to filter out the results of our network. Let's say that we would like to see let's say that we would like to filter the HTTP or ARP packets from this network capture that we have in front of us. So we are going to go ahead and type HTTP. As we said, we would like to see either HTTP or ARP or both. So HTTP, then you apply these double bars, and then you type ARP. So this is the condition, which means source. So we are going to filter our results by hitting enter, typing this HTTP double bar ARP, and the results will include HTTP or ARP traffic, or both if they exist in that network capture file that we have. So let's just go ahead and hit enter. And you will see that the only results that we see are ARP, protocol, traffic, and HTTP protocol traffic, because this network capture file that we have included both the protocols. You can also apply the end condition in the filter. So this filter helps you filter the packets that match exactly the conditions that you are going to type in the display filter. So let's say that, for example, there is a requirement to filter the HTTP packet that have the HTTP packets that have a specific source IP. So let's just go ahead and use this filter and type HTTP end, and then we would like to write the source IP that we would like to see the HTTP traffic coming from. So we can go ahead and type IP.src equals, and then we are going to choose like an IP from our traffic that we captured. So let's just go ahead and type an IP address. Then we hit enter, and then we will see all the HTTP traffic that are originated from the IP that we typed in the filter. So it's a short result, you can see, because both the conditions are met, and we see the HTTP traffic that is originating only from that IP address. You can also filter by port number, and this can be applied in the filter by typing tcp.port EQ80. So this basically means that we would like to see the traffic coming from the port 80. So tcp.port equals 80. You just hit enter, and then you will see all the traffic that is going into our port 80 and also leaves our port 80 to communicate with another destination IP source. We can also reject packets based on a source IP or destination IP, and for this, with this filter, we are just filter out all the results from that coming in or out from a specific IP address. So let's just go ahead and let's say filter out the results that they have a destination IP that we are going to choose later on. So let's just type IP.dst, which is the IP, the destination IP, and then exclamation mark equals, and then the IP address. So we would not like to see the traffic destined to that IP address, and we hit enter. So after we hit enter, we can see that all the results that they have a destination IP, the destination IP that we applied on the filter, they disappeared from our results, so we cannot see any traffic that is destined to that IP address 192.168.1.1 anywhere in our search results. So in this video, we learned how to apply filters in Wireshark so we can filter out the traffic that we don't want or we want. So we learned to filter out results by source IP, by destination IP. We can filter by protocol. We can use conditions such as OR and AND in the display filter, and also we can filter by port number. Let's say that we would like to see the traffic coming in and out of a specific port, and also we can filter out results from our network traffic that we would not like to see. Let's say we would not like to see any kind of network traffic going to a specific IP address. So that's it for this video. You can just go ahead and click on the next video called Identifying Open, Closed, and Filter Ports with Wireshark. Hello guys, and welcome to another video for this chapter. In port scanning, there are three port statuses: open, closed, and filter port. Open port means that the port is open and running a service for the machine. Closed port means that the port is closed and not running any services. Filter port means that your probe to those specific port is filtered or dropped by the firewall. For this test, we are going to use Nmap to scan one of our Windows systems, and we are going to use the Nmap command with the flag -F in order to scan fewer ports and show you guys how the results that the Nmap will present to us confirm are translated in Wireshark. So let's just go ahead and type the Nmap command with the flag -F, and then we are going to type the IP address of our Windows system. Before we press enter and start scanning with Nmap, we select our network interface and start capturing the packets. And we hit enter on Nmap, and now we can go ahead and stop the capturing on Wireshark. So as you can see here, Nmap presented us with some results that came back from the target machine, that there are a few ports open. So let's see how that is translated in Wireshark, and we can see also how a closed port is translated in Wireshark, and where are the rest of the SYN packages go when they're hitting other ports. So as you can see here on Wireshark, let's start from the beginning. So there is, from the moment that we pressed enter on the Nmap command, we send SYN packages to each port of the targeted machine. So you can see that from this is our port here, and we are sending a SYN packet to each of these ports on our target machine. When there is traffic like that, it means that there is no reply at all from the target machine. We are just sending the packet and we don't receive an answer. This means that the probe packet we sent is not even reaching the port that we are sending it, and that is because it's dropped by the firewall. So when you see traffic like that, it means that our packet is dropped by the firewall. So as you can see also from our Nmap results, there is quite a few open ports in our target machine. So let's see how is that translated, what is the response that we get from that machine in our Wireshark in order to realize that this port is open. So let's just go through the results, and you can see here that we have an RST reply. So you can see here that when we are sending a SYN packet to the port 135, we receive an RST reply, which means that the port is open, as you can see, and it's in the same manner. We have the same RST on port 139, and we can say the same for, yes, the ports 3389 and 445, that when we are sending the SYN packet and we have this RST, these ports are open. So even if we are capturing some network traffic and we don't know there is an Nmap going on, we can pretty much see it here. So when there is RST, this port here is open, and the rest are filtered by the. So let's just go ahead and how the closed port, in this case 49155, is being translated into Wireshark. So as you can see here, if we scroll down and we find the 49155, we can see that it's sent to our port, to us. This is our local IP address. This is the target machine. So it sent an RST ACK, which means that this port is closed. So that was it for this video. I hope you enjoyed it. You can go ahead now when you're ready to click on the next video and understand a lot more about Nmap scan with Wireshark. Hello guys, and welcome to another video on this chapter. In this video, you will learn how to capture network packets using Wireshark when an attacker is scanning a target using the Nmap port scanning method. Hence, you will notice how Wireshark captures different network traffic packets for open and closed ports. So let's get started. So here in our Kali Linux machine, I have opened the terminal and the Wireshark side by side, so we can explore how Nmap interacts with open and closed ports and how that is being translated into the Wireshark. So let's start with a TCP scan. A TCP scan will scan for TCP ports like port 22, 23, 445, etc., and ensure for listening port through three-way handshake connection between the source and the destination port, of course. If the port is open, then the source will make a request with SYN packet. A response from the destination will be sent as a form of SYN ACK packet, and then the resource will send an ACK packet, and then again the source will send another RST ACK packet. So let's see how that is being translated. First, how we are going to type the Nmap command. So we are going to use Nmap, the dash ST for the stealth, for the TCP scan, and then we are going to choose any port. In this case, it will be 445, and we are going to choose a local address in my network that I have this port open. So before we hit enter, let's go ahead on in Wireshark, choose the network interface, start capturing, and then we are going to hit enter on our terminal. So let's go ahead and type the Nmap command that we are going to use. So Nmap, we are going to use the dash S capital T for the TCP scan, and then we are going to choose port, any port. In this case will be 445, and we are going to target a Windows system that I have set up in my local network. And before we hit enter, we are going to choose our network interface, start capturing, and then we're going to hit enter, and then we're going to go back to our Wireshark and stop capturing. So as you see, we did a stealth scan on port 445 and it returned that it's open. So if you look over to the sequence of the packets here, so this is the 8.188 is our Kali Linux IP, and 123.8.123 is our Windows IP. And as we discussed earlier, you see that the Kali Linux machine is sent a SYN packet to 445 port of Windows system, and then 8.123, the Windows system, replied with a SYN ACK to our Kali Linux machine. And then our Kali Linux machine sent an ACK, and then again the source, our Kali Linux machine, sent an RST ACK packet, signifying that the port 445 on our target machine, in this case our Windows machine, is open. So let's clear this out so we can capture the next traffic when the port is closed. So we are going to use a port that we already know that is closed. So let's use port 22 on 8.124, and before we hit enter, let's start capturing again and hit enter on Nmap. Go back to Wireshark, stop the traffic capture. As you can see, Nmap returned that the state of the port 22 is closed. So usually when you're doing a TCP scan on a port and the port is closed, usually the sequence goes like the source is sending a SYN packet to the destination port, and then the destination replies with an RST ACK packet to the source, signifying that the port is closed. So let's see how is that being translated into Wireshark. So here we are. We see that our Kali Linux machine sent a SYN packet to 124. This is another Linux machine on port 22, and our destination, our target IP 8.124, replied to our Kali Linux machine with an RST ACK, as we said, signifying that the port is closed. So let's go ahead and clear this one more time. Clear our terminal as well, and let's explore what happens on a stealth scan. So a stealth scan, more simplified, a SYN scan, is the default and most popular scan option for good reasons. It can be performed quickly, scanning thousands of ports per second on a fast network, and it is not hampered by restrictive firewalls or any kind of firewall. It is also relatively typical and stealthy since it never completes TCP connections. So normally when you are doing a stealth scan on a port, the sequence of the packets when it comes to communication between the source and the destination goes like that. The source is sending a SYN packet to the destination. Destination replying with a SYN ACK packet to the source, and then the source sends an RST packet to the destination. So let's see how are we going to use Nmap for that result. So we're going to use Nmap, the flag SS -S and then capital S, which is the stealth scan, and we are going to use port 445 that we know that is open on the 8.123 target. Just remember always to start capturing before you hit enter for nmap, and then we hit enter, and then we can see that the port is open 445 on our target machine. Go back to Wireshark, stop capturing all this traffic. Then you can go back and search for the IPs. As we said, 8.188 is the our Kali Linux IP, and we send a packet to 8.123 on the port 445. So as we said, the port is open, so our Kali Linux machine sent to our target machine a SYN packet. The target machine replied to our Kali Linux machine with a SYN ACK packet, and then our Kali Linux machine sent a reply to the destination IP on port 445 with an RST packet, signifying that the port 445 is open. So let's figure out now how the traffic is looking for a closed port using a stealth scan. So in this case, we're going to use the same command, but we're going to use a different port this time. This is going to be port 22 on our 8.124. Before we hit enter, we're gonna start capturing the packet, hit enter, and as you see, the scan has finished on port 22 and it's a closed port. And let's see how is that being translated into Wireshark. So let's go back. Okay, so here we are. As you can see, our source IP sent to our target machine a SYN packet on port 22, and the target machine replied to our Kali Linux machine with an RST ACK packet, thus signifying that the port is closed. So that is usually how the sequence of the packet is looking when you're using a stealth scan on a closed port. So let's clear out everything one more time so we can go to the next scan that we are going to explore. So we are going to do now a FIN scan. In general, a FIN packet is used to terminate the TCP connection between the source and destination port, typically after some data transfer is complete. In the place of a SYN packet, Nmap starts a FIN scan by using a FIN packet, of course. If the port is open, then no response will come from the destination port when a FIN packet is sent through the source port. So let's see how is that being structured on an Nmap command, and see if that will translate correctly. This transaction will translate correctly to in Wireshark. So Nmap, we're going to use the -SF for the FIN scan. Then we are going to choose again port 445 on our destination IP, which is going to be 8.123. Start capturing, then we hit enter, So let's see how the nmap command will be structured when it comes to a finscan. So we're going to type nmap. We're going to choose the S capital F flag for the finscan, and then we are going to choose port 22, 192.168.8.194. So we start capturing before we hit enter. And then you can go ahead and stop the traffic capture from Wireshark. As you can see, the port 22 on our target machine is open. So we can see how is that. We can go and look over the sequence of the packets and see how is that being translated. So if you go to Wireshark, you can see that our Kali Linux machine 188 sent to 8.194, our target machine, a FIN packet on port 22 as we specified in our command. In fact, they sent two FIN packets and there was no reply after that. You can see that in the stream of packets there is no 192.168.8.194 replying to our Kali Linux machine. So let's clear this out. Now Wireshark first, and then we can see that if a FIN scan is performed against any closed port, then the source port will send a FIN packet to a specific port, and destination this time will reply by sending an RST ACK packet. So let's use the nmap command again with the flag SF on port 22 again, but this time we are going to target 8.124. We start capturing and then we hit enter to send a FIN scan on the closed 22 port. So let's see back in Wireshark how is that being translated after we search a little bit our IP, and yes, you can see here that our Kali Linux machine sent on the 8.124 target a FIN packet on port 22, and the target IP replied to our Kali Linux machine with the RST ACK packet signifying that the port is closed. So let's move on now to another type of scan and see how that type of scan will behave, and we can check how it's been translated into Wireshark. So the next in our list is a null scan. Null scan is a series of TCP packets which hold a sequence number of zeros. And since there are no flags set, the destination will not know how to reply to that request because it's basically like receiving nothing. So it will discard the packet and no reply will be sent, which indicates that the port is open. So let's see that how we're going to structure nmap command by using nmap. This time we're going to use the SN flag. We're going to choose port 445 on our target, which is going to be .123. We start capturing and then we hit enter. So let's see how the nmap command will be structured for a null scan. So it's going to be nmap dash, we're going to use the SN for the null scan flag. We're going to choose port 22 on our target, which is going to be 8.194. So we start capturing before we hit enter, and let's go ahead and hit enter. You can see that the port is open on 22 on our target 8.194. So we stop capturing, and we go and look how this transaction happened in Wireshark. So as you can see, our Kali Linux machine sent to the target specified in our command, which is 8.194, basically none packet, so 0 packet on port 22, and there was no reply after that. So you can see 193 responded to another type of address and so on. So there is no reply from 194 to 188 in the next sequence of packet. So let's figure out how the sequence of packets look like when we're using the null scan on a closed port. So this will be kind of the same command, but we are going to choose a different target that we know that the port is closed. So we're going to do a null scan on a closed port, and we start capturing. We hit enter. You can see the port is closed. We stop the capture, and we go back to where the command is happening. So you can see that our target here received on port 22 a null packet, and it replied immediately after that to our Kali Linux machine with an RST ACK packet, which, as we discussed earlier as well, that signifies that the port is closed. So next we are going to do a UDP scan. UDP scan works by sending a UDP packet to every destination port. It is a connectionless protocol. For some common ports such as 53 and 161, a protocol-specific payload is sent to increase the response rate. A service will respond with a UDP packet proving that it is open. If no response is received after retransmissions, the port is classified as open filtered, as we already saw in some of our demonstrations so far. So this means that the port could be open, or perhaps the packets are filtered, or perhaps packet filters are blocking the communication. So let's construct the nmap command by using the flag SU, signifying the UDP scan. We're going to choose port 161 this time on our target machine, which is going to be 8.123. So we start capturing, we hit enter, So we are going to go on our terminal and type nmap. We're going to choose the flag SU for the UDP scan, the port 161 on our target machine, which is going to be 8.186 this time. So we're going to start the capture before we hit enter, and as you can see, the reply is open or filtered, as we discussed earlier on our port 161. So let's go to Wireshark once again. Let's filter out all this traffic. By the destination IP address, and you can see that as we discussed, there is a GET request from our Kali Linux machine to the target, actually twice, but as you can see, there is no response that is received from the target machine. So that, as we discussed earlier, classifies the port as open or filtered. So let's clear this out and see how the UDP scan will be translated in Wireshark. So we're going to use the same command, but we are going to change the target now on, and this is going to be on the same port. So in this case, if the source is sending a UDP packet on a closed port to the destination, then the destination sends a reply with ISMP packet, port unreachable. So let's see how is that going to be viewed in Wireshark after we hit enter on the nmap command that we just prepared. First we start capturing and then we hit enter. You can see that the port is closed, 161. And let's review that in Wireshark. So you can see that our here it starts. Our Kali Linux machine 8.188 is set into our target, which we specified in the command 8.124. Is sending a UDP packet, a GET request, and the destination IP 124 is replying, as we said earlier, with the destination unreachable. So that means that the port 161 on our target machine is closed. So the final scan that we are going to explore how its results are being translated in Wireshark is the XMAS scan. So these scans, as are we going to explore more in depth in later chapters and videos, are designed to manipulate the PSH, URG, and FIN flags of the TCP header. So by setting the FIN, PSH, and URG flags, it's basically lighting the packet up like a Christmas tree, as we say. So when the source sends these type of packets to a specific port, and if the port is open, then the destination will discard the packet and will not send any reply to the source. So let's go ahead in our terminal and type the nmap command with the flag, this time -s capital X for the XMAS scan. We are going to choose port 445 in our target machine, which is going to be 8.123. So let's just go ahead and start capturing first. Hit enter. So let's just go ahead and type the nmap command by choosing the flag -s for the XMAS scan, and then we are going to choose port 445 in our target system, which is going to be 8.194. So we start capturing first the traffic from on our network interface. We hit enter. You can see that the port 445 is open in our target machine, and then we go to Wireshark and we will try to find this transaction. Okay, so you can see here that our Kali Linux machine is sending to our target, as we specified, 8.194 FIN PSH URG packet, actually twice, and after that there is no reply from the destination IP, signifying that the port is open. So the XMAS scan for the close port will be in the same manner, meaning that the source will send a FIN push URG packet to the destination, and the destination this time will reply with an RST ACK packet to the source, as we said, classifying the port as closed. So let's just go ahead and use the command again. This time we're going to choose port 22 on 8.124 target. We start capturing and then we hit enter. You can see the port is closed. So let's see how the nmap command is being translated in Wireshark. So as you can see, we found it already here. 8.188, our Kali Linux machine is sending to our target machine 124 a FIN push URG packet, and then immediately after that our destination target IP is replying to our Kali Linux machine with an RST ACK packet, signifying to us that the port 22 is closed. So as you saw today, we gained a deeper understanding into how various scans are behaving on closed and open ports, and we gained a deeper understanding into investigating those packets with Wireshark and how each scan behaves. We used the TCP scan, the SYN scan, the FIN scan, the null scan, the UDP scan, and the Christmas scan. So that was it for this video. I hope you have gained a deeper understanding so far how Nmap interacts with the ports using different types of scans with the help of Wireshark, of course. So you can just go ahead now and click on the next video, where you're going to get a deeper understanding on the ICMP protocol, analyzing it with Wireshark. Hello guys, and welcome to another video on this chapter. In this video, we are going to learn how the ICMP protocol works with the help of Wireshark, of course. ICMP, or Internet Control Message Protocol, is Internet or Network Layer Protocol. In general, it is used to check the reachability of a host or router in a network. Ping or Traceroute uses ICMP as inner protocol. Ping uses ICMP echo request and ICMP echo reply messages to check whether destination host is reachable or not. Although ICMP packets have a data section, their purpose is not to wrap and carry protocols like HTTP and DNS. Instead, it is designed as a low-level management protocol for the internet. So the ICMP packet size at the network layer consists of the first IP header, which is 20 bytes. It occupies 20 bytes. Then is the section that is called the ICMP header, which in total consists of 8 bytes. As you can see, the type, which is 1 byte, the code 1 byte, and so on and so forth. And the last one, as we said, is the data section, or ICMP payload, which occupies the rest of the bytes, which means in this case is 1472 bytes maximum. Of course, in the data section, it can be used less than that, like 30 bytes or 1000 bytes, and so on. The maximum transmission unit, the MTU, the IP maximum transmission unit, the MTU, for the network layer is 1500 bytes. Now, the size of the ICMP packet at the data link layer, it's a little bit more, and that's because of the Ethernet header sitting on top, which occupies 14 bytes, and then it is the same. The IP header occupies 20 bytes. As standard, the ICMP header is 8 bytes, as we discussed before, and in this case, the data section, the ICMP payload, is again 1472 bytes maximum. In total, if you add the Ethernet header for the data link layer, the packet size, the ICMP packet size, is 1514, the maximum transmission unit. So the ICMP query codes are type 0, which is the echo reply, type 8, which is the echo request, type 9, which is the router advertisement, type 10, the router solicitation, type 13, timestamp request, and type 14, timestamp reply. A ping command sends an ICMP echo request to the target host. The target host responds with an echo reply, which means the target host is alive. So as shown in these two slides, a ping packet, and any ICMP packet in general, is fairly simple. The first two values in the packet are the type and code indicating the purpose of the packet. Then the packet contains a checksum, which is important since a single bit flip in the type or code can convey a completely different error message. After that, ping packets contain identifiers and sequence snappers. Since ICMP is a stateless protocol, these values help to match a response received by the sender to the corresponding request. The ICMP error codes are type 3, which means destination unreachable, type 4, source sequence, type 5 is a redirect, type 11 time exceeded, and type 12 parameter problems. The ICMP protocol is designed to provide error information and perform simple diagnostic actions. As such, Even passive monitoring of ICMP traffic on a network can provide a wealth of data to an adversary. Eavesdropping on ICMP packet can help to identify the hosts on a network and if certain systems are up, down, or malfunctioning. So let's just go ahead on our command prompt and try to explore the ping requests. At the same time, we will capture the traffic and see how that it translates on Wireshark. So start capturing, and then let's go to our command prompt. So let's just explore the simple command and see what happens. Let's just ping an IP address. So let's just go ahead and ping an IP address. So as you can see from the below results, after we pinged an IP address, you can see that there is a reply from the host, and there is also a couple of more things. You can see that the default size of the payload sent by our machine in this case is 32 bytes. This is the request. The same size of payload received by the source machine, which is 32 bytes, from the destination machine. This is the reply. The total packets are 8. 4 packets are sent and 4 of them are replies to our machine. So let's go to Wireshark and check how all this information being translated. So let's just capture the traffic. So let's just stop the traffic, capture, and we can filter the results with the IP address, the destination IP address. So we pinged 192.168.8.254. So also now that we found the ICMP protocol column, we're going to have a look at this information. So as you can see, the length is 74, and it starts with the request from our machine. It's an ICMP echo request. So that means that the length, the 74 bytes length, is consisted of the data, the payload size, which is 32, the ICMP header, which is 8 bytes, the IP header, 20 bytes, and the Ethernet header, 14 bytes, as we discussed previously on the slides that we were explaining the ICMP packet size. So if you highlight the first ping request and go to below Internet Control Message Protocol, you can see that this is a type 8 echo ping request indicated here. You can see also that the reply from the other machine, the other IP address that we pinged, is in the same length. When we ping an IP, sometimes we don't get an echo reply from the host machine. Instead of that, we get some replies such as destination unreachable or time exceeded. And these, as we discussed earlier in our slides, these are the ICMP error codes. There are many reasons behind such kind of error message. Possibly a host in a network is down, or firewall is blocking our ping request, and so on. So let's just ping an IP address that it's not reachable. So you can see after we ping this IP address, which I know this machine with this IP address is right now powered on, but but the firewall is blocking our ping request. Now, since we captured this whole transaction between these two machines with Wireshark, let's just go to Wireshark and check what the information saying there. Let's just filter out with the ICMP protocol on the display filter, and you can see that when we try to ping that IP, this destination IP was not reachable. As you can see in the Internet Control Message Protocol, the error code is type 3 destination unreachable. We can also use flags with the ping command when we are pinging an IP address, and we can use, in this case, ping dash A, and let's just ping again. So in this case, dash A resolves the IP address to a host name, identifies that the reverse name resolution is carried out on the host IP address. If it is successful, ping shows the matching host name. Let's go hit enter. So as you can see, we've got a name back. In this case, this is my router named Arcadian, and you can see that the reply, and you can see that the ping shows the exact matching name of that device that we just pinged. Let's just go to Wireshark as well and check what is going on there. Let's just stop capturing the traffic again and filter out by ICMP. So you can see in the same manner we have an echo ping request and a reply from our router with the same length. By default, the ping command sends 4 packets of the request and receives the same number of the packet as a reply from the host. You can also increase or decrease this number of the packet by using the command with the flag -n. So we can ping -n and we can send 8 packages to destination IP. So as you can see, there is 4 packets of request. So as you can see, we had this -n as 8 packets of request, and thus we received back as a reply 8 packets. As we have discussed, The default size of ICMP payload is 32 bytes, as you can see also from the command prompt. The maximum is 1472. If the size of the payload packet is greater than that, then the packet gets fragmented into small packets. So we can modify the size of the payload using the command ping-l, and this time we are going to have 33 bytes of the payload, and we are going to send it in this same destination IP, and see what happens. So now let's go to Wireshark and see what's going on there. Let's filter out by ICMP protocol, go all the way down. So in the last ping that we changed the payload size, as you can do the math, the length of the packet when we send the request and the reply changed to 75 because the payload bytes increased. So let's just go ahead now and try to send the maximum size of payload using the following command -l, the same, and as we explained, the maximum payload size is 1472, and we're going to use again the same destination, host IP, which is a router. Press enter and see that the bytes have changed. Let's go to Wireshark now and see how is that information translated there. We again filter out by ICMP, and as you can see, the length changed to 1514 as we explained. So when the size now of the payload is greater than 1472 or too large for a network to hold and reach a router, the router breaks it into smaller packets, which are called fragments. So let's just go ahead and explore this situation by typing ping-l in the same manner, and then we are going to type 1473, or you can type 1474, then the destination IP, and see what happens now in this case. So let's explore this situation in Wireshark and see how the packets are being broken into smaller packets. So back to our Wireshark. So back after we stop capturing the traffic, we can go ahead again and type ICMP and filter out the results. And you can see that, so let's just go ahead and filter out by the destination IP and check for any ICMP packets. So as you can see from the results, we are being presented here with the length 1514 as fragmented protocol. So If you do the math that when the payload is more than 1472, it gets fragmented and it sends the maximum MTU, which is 1415, and what is also added is the remaining MTU capacity, which is 36. So you can see it sends for 15, 14, and then 36, and then a series of reply, and then the same. So now in these results, we don't see it one following each other. But this is the way it's been broken down into small packets. We can also use the -F option with the ping command, and this type of option will not allow the packet fragmentation in the network. So let's just go ahead and use the same command as before, but this time before -L, we're going to type -F. So we are not going to let the packet being fragmented into smaller ones. So let's just hit enter. And you see that we receive the information that the packet needs to be fragmented. So let's just move right away to Wireshark and see how that information is being translated. So if we filter out by ICMP protocol again, so we can have only the results of our ping command, you can see that we are receiving the destination unreachable error, which means that the packet didn't go to our destination IP because it needs to be fragmented first. It was too big for the network to transfer it to the destination IP. So that was it for the last video of this chapter, and when you're ready, you can move on to chapter 2.
Did you know that you can be part of the lucrative cybersecurity industry? Even top companies like Google, Microsoft, Amazon, IBM, Facebook, and Dell all hire cybersecurity professionals. The cybersecurity industry has a 0% unemployment rate. The average salary for an entry-level cybersecurity job is about $100,000 per year in the United States. Furthermore, you don't need to know coding and learn from your home, and you get a scholarship to kickstart your career. Apply now. EC Council is pledging a $3.5 million CCT scholarship for cybersecurity career starters. Scan the QR code on the screen to apply for the scholarship. Fill out the form.
Hello guys, and welcome to the first video of chapter 2. In this chapter, we are going to focus on analyzing unusual traffic, delays in packets or lost packets, and in general how to investigate all sorts of network traffic packets, and learn, of course, how to decrypt traffic such as Wi-Fi traffic. So for the first video of this chapter, we are going to focus on HTTP and learn how to analyze it. And of course, we are going to go through some practical examples on how to detect HTTP errors. It is used by the World Wide Web, and it defines how messages are formatted and transmitted by a browser. HTTP also defines what actions should be taken when a browser receives HTTP command and for transmitting HTTP command to get data from the server. For example, when you enter a URL in any browser of your choice, it actually sends an HTTP command to server, and the server replies with an appropriate command. So now, let's get to know about the methods which are seen quite often. These methods of HTTP that we mostly see is GET. GET request asks data from a web browser. This is a main method used for document retrieval. We will see one practical example of this method real soon. And the other method is post. This post method is used when it's required to send some data to the server. So let's try something practical to understand how HTTP works. For the purpose of this video, we are going to use the vulnerable web app that I have set up in my Windows system, and we are going to access it through our Kali Linux machine. As you can see, I have uploaded a picture here in the file upload section of this website, and we are going to use it to download this picture while we are capturing the traffic, so we can go ahead and analyze this HTTP traffic that we are going to capture. So before we continue here, let's just first go to Wireshark, select our networking interface, and start capturing. So now let's go to our browser and try to save this picture. In our computer. Now we can stop capturing the traffic, and we can go through this whole procedure and analyze its method of HTTP used. So before we go into HTTP, we should know that HTTP uses port 80 and TCP as transport layer protocol. So now let's see what happens in the network when we put that URL and press enter and we are trying to save something. So let's start and find the initial interaction. Okay, so you can see here that the interaction started with us sending a SYN packet, and then the server responding with a SYN ACK, and finally, as you can see, our machine responding with an ACK in order for the connection to be established right now. This is the TCP three-way handshake, and then the we have the HTTP GET command that we initiated while we were trying to download this JPEG file. As you can see, transactions of packets while we are downloading this JPEG, and then at the end there is this HTTP OK in order to assure us that the whole download of the file has been completed. So after TCP three-way handshake, like we explained earlier, HTTP GET request is sent to the server, and we are going to go through some important fields in that packet, and we're going to explain and analyze what each one means. So let's just go to the GET request and then go to the HTTP protocol. So let's just maximize this a little bit. So you can see this packet is a GET request followed by the link that we have used to download the JPEG file. You can see also the version of HTTP here. In the next step, we have the host. This is the web server name where the client, in this case us, setting the HTTP GET request. In the next line, you have the user agent. This is our browser type. So in the next lines, we have the accept language, which is as it's being defined, the standard accepted language that we used. Then we have the accepted encoding from client side. The connection keep alive is the connection controls whether the network connection stays open after the current transaction finishes. And at last, it's the referrer, which is the full URL that we try to access. And at last, you can see the full request for this JPEG file that we try to download. So after this initiation from our side, the HTTP GET command in order to download this JPEG file, there is a sequence of TCP packets going back and forth from the server to the client while we are downloading the file, until the file is downloaded and we received an HTTP OK that the JPEG image has been downloaded. So let's just dive a little bit deeper into this HTTP 1.1 200 OK. So you can see that in the first line we can see the HTTP 1.1 200 OK, the status code sent by the server, and the response. 200 is the status code by the server, and OK is the response phrase sent by the server. Next, we have the date that this action has been completed, in this case the download of this JPEG image. In the next line is the server in which this file that we downloaded has been hosted there and we downloaded from. The last modification date, this signifies the date that the file was last time modified. And then in the next line we have the E tag. So the E tag indicates the content is not changed to assist caching and improve performance. Or if the content has changed, E tags are useful to help prevent simultaneous updates of a resource from overwriting each other. In the next line we have accept ranges. Bytes. Byte is the unit used in the server for content. Content length. This is the total length of the file that we have downloaded in bytes in general. Keep alive parameters, again in the next line. The connection keep alive, as we mentioned earlier also, it was in our HTTP GET method. The content type is the type of the file that we downloaded. You can see in the next few lines the request URL, and that is it for analyzing the HTTP 200 OK packet. So now we know what happens when we request any file that is present in a web server. HTTP is a simple application protocol that we use every day in our life. It's not secure, so HTTPS has been implemented. The S stands for secure in the HTTPS. So you can see lately that most of the web server names, if not mentioned all, start with HTTPS and then the website. This means that all communication between you and the server are encrypted nowadays. So now we are going to look for HTTP error responses. As you can see, I have opened a pickup that I know it contains errors, so we can explore them. Usually the HTTP errors you can find in a network capture file are 300 errors, which are redirects, 300 and above, like 301 and 302 and so on, which are redirects, 400 and above errors, like 401, 402, 404 are client errors, and 500 and above are server errors. So Wireshark has some HTTP statistics that can show us of all of those response codes in one location. So you can go to statistics, HTTP, and you may want to go and press packet counter. So as you can see, Wireshark generated from this file that we have open all the requests, and if you expand, as I already have it, expand here. So as you can see, we have here we had in total 91 HTTP packets, and we had 2 client errors in this pickup file and 43 successfully transferred packets. So let's see now how you can apply display filters to find these kind of errors way more faster and convenient for you. So you may want to go to the display filter section and type http://response.code. So now in this case, you can use, as you can see from the indication, like if you are searching for exactly 300 errors, like redirects, you can use the equal sign and then type 300 and press enter. And in that case, you're looking for specifically 300 errors only. You can do that with 301, press enter, errors. As you can see, we don't have redirects in this pickup file as we saw from the statistics and the packet counter before. Now, you can use the greater sign in this display filter. So you can use http://response.code greater and equal to 300. So in this case, the results from applying this filter is that it's going to show us all the errors above 300. So that means 301, 302, 400, 500, all the errors that exist in this network capture file. So if we hit that, we're going to see all of the errors. If we are going to focus only on 300 errors, which are the redirects, we may want to go and press end http://response.code. We would like that to be below 400, or you can type that below equals 399. So in this case, if you press enter, the results will be all the 300 errors. You can apply the same for 400 if you want to see only 400 errors, and also you can apply the same filter that I have here, and you can substitute 300 with 400 and 399 with 499 to prevent 500 errors from appearing in your results. So let's just go ahead and apply for this filter for 400 errors. So we would like to change these to 400 and these to 499. We hit enter, and in fact you can see that there is some client errors appear in our results. So let's just go and try our final one to see if there is any 500 errors. As you can see, there are none because we used the command with greater equals to 300 that presented us all, that will present us all the results from 300 and above. So as you can see, there is no server errors in this network traffic capture file. So that was it for today, and now you can go ahead and click on the next video and learn how to check out sneaking non-standard port use. Hello guys, and welcome to another video on this chapter. One of the checks that should be a standard practice, in my opinion, involves finding out if an app uses non-standard security ports and protocols, either you are on the defender side or the attacker side. However, there are thousands of ports and quite a few protocols to look at. In this video, we are going to learn how to check out sneaking non-standard port use. A non-standard port just means a service running on a port other than its default. This is usually how a port is defined by default. A non-standard port just means a service running on a port other than its default. The IANA port numbers registry that you can find in the link provided in this slide, you can check the standard ports. A non-standard port just means a service running on a port other than its default. Services use some default ports that are usually defined by the IANA port numbers registry that you can actually check out on the link provided in this lesson. Running a service on a non-standard port doesn't really mean particularly something specific security-wise. It may reduce the amount of noise that a defender has to deal with in terms of automated scanning on the internet, where bots usually target common standard ports for vulnerabilities. Moving SSH from 22 to, for example, let's say 55522 might reduce the number of drive-by brute force attempts. So either you are on the defender's side or the attacker's side. In order to find all the services running on a system, one can use Nmap or a similar tool. And for example, you can use the command nmap space dash s capital S space dash a space dash pn space dash t4 space dash p1 to 65,535 space the target IP. So let's break down a little bit this command. The dash SS tells Nmap to perform a TCP SYN scan. The dash A enables a range of options related to operating system detection, service detection, and script scanning. Dash PN tells Nmap not to use a SMP ping to check if the host is up. Dash T4 sets the speed of the scan. Usually the valid arguments are 0 to 5. Usually the valid arguments are from 0 to 5. Dash P1 to 65,535. That's the port range. So as somebody is handing down both standard and non-standard ports, this is the only way to cover everything. The results of this command should show you any ports that are open and what services are running on them. From there, it's an open question as to what protocols are considered a potential avenue of attack. SSH or Telnet might be useful, but unless they use a weak username and password, it's probably not interesting. They might run an HTTP server on a non-standard port with a vulnerable web application being served, and that might be of interest too. So the possibilities are quite endless. You can use Wireshark for that matter once you've identified ports and services that are running on them to record any kind of sneaky traffic. By utilizing the display filter section on Wireshark after you have captured all the desired traffic, you can focus on, let's say, SSH traffic, for example, by typing SSH in your display filter. And this will filter out all the unwanted results from your huge traffic capture file and show you only the SSH traffic. You can perform the same for any other service that the traffic you would like to inspect from, or you can use specific ports that services are running on by utilizing, let's say, the filter tcp.port equals 80, like we discussed in the previous lesson. Generally, you are not introducing a new vulnerability by running a server on another port. The software will behave the same way regardless of what port it listens to, unless of course there is a vulnerability in the code that parses and sets custom ports. Though you may find sometimes that your clients cannot connect to your server because a firewall or an intrusion detection system notices bad traffic, since it expects the right protocol on well-known ports. And if you are in an enterprise environment, those firewalls and intrusion detection systems will likely be flooding you with false positives, making it harder to detect legitimate threats among the noise. And the lesson may be hinting at naive security where an admin thinks that they have protected themselves from FTP vulnerabilities by closing off ports 2021, and you are opening FTP vulnerabilities by putting an FTP server on port 22, let's say, which is open generally to the world. The FTP software isn't more vulnerable here, but the system as a whole may be. Say, for example, you have a website with a vulnerability that allows them to take control of your Apache Nginx web user, and your SSH server has a vulnerability that can crash it. The web user can crash the SSH server that starts their own. The web user can crash the SSH server and start their own. And because it started on a port, let's say above 1024, nothing will prevent it. As soon as you can send your password to that SSH server, either to log in or use a sudo to gain root privileges, the attacker can gain whatever privileges you have as well. In general, I wouldn't call that a high severity vulnerability, but if an attacker can gain access to a non-root user on your server, and your server is expected to run trusted services on port above 1024, let's say, it can be an unnecessary weakness. The non-standard ports are in general targets for exploitations. It may not be so desired or high priority, but it's still a target for exploitation. It is like locking the front door of your house, but leaving the windows open. So in general, locking the front door of your house, but leaving the windows open, isn't a sound security strategy. That's why cybercriminals are targeting a range of non-standard ports to ensure the payloads can be deployed undetected. In a recent research, 19.2% of all malware attacks came across non-standard ports for the year 2018, which signifies a rise of 1.5% comparing to 2017. Most organizations aren't safeguarding this vector because of performance or cost concerns, leaving millions of attacks unchecked. So that was it for this video. I hope it was quite informative for you. And when you're ready, you can go ahead and click on the next video where you're going to learn how to investigate lost packets with Wireshark.
Hello guys, and welcome to another video of this chapter.
In this video, we are going to learn a few ways to investigate lost packets while doing network traffic analysis with Wireshark.
So once you have fired up Wireshark and captured the desired traffic that you would like to search for lost packets, or as in my case, you have captured some network traffic and you saved the results, you can open the pickup with Wireshark and you can just go ahead and try to investigate. So there is two ways you can do this analysis. The first way is to just go through the stream of your network traffic capture here, and as long as you can suspect that there is some kind of lost packets going on from a specific source to IP, you can just go ahead and click, go to Internet Protocol version down here, and you can use the identification number. So we have this hex number and the normal decimal number. You can just go ahead and add this as a column, and here in the identification column, you can see the numbers and the sequence of the numbers from this source IP to the destination IP. You can just go ahead and look for any inconsistencies, like missing numbers in between. Like it says here that we have 19679 and then 680, 681, 82, 83, and you can just go ahead all the way down and see if there is a number that was skipped. That will indicate that you have lost a packet. You can do this from any source IP in the network traffic that you captured. So you can see, like, from okay, so in this search, it doesn't seem that we have a lost packet here. So this is the kind of thorough way to go through each and every line of the stream of your network traffic capture. And it's also time consuming, but if you have the time, you can just go through and
this traffic and filter by source IP. If you would like, you can filter out by each source IP that exists in this network capture of yours. Another way is that you can utilize some specific filters in order to make your life easier. One of these filters is TCP.analysis.lost_segment. So you can just go ahead and apply this filter, and you will see that from this source IP to this destination IP, there was a loss of packets. As you can see in the IFU, and the previous segment was not captured, so you found a gap right there in the sequence. So that indicates that we have seen a gap in the sequence number. So packet losses can lead to duplicate ACKs, which leads to retransmission, and that leads us to the second filter you can apply, which you can see all the retransmissions in the capture. So you can go ahead and type TCP analysis.retransmission. You can hit enter, and you can see the retransmissions in this network traffic capture. A few retransmissions are okay, but if you have like excessive retransmissions, like more than necessary, I would say, then you should be alarmed. This usually shows up as a slow application performance and or like packet loss to the user. So these were a few ways you can utilize in order to analyze some network traffic capture analysis that you've had. So that's it for this video, and you can just go ahead and click on the next video called Capturing Wireless Traffic on a Selected Network.
Hello guys, and welcome to another video for this chapter. Identifying vulnerable devices and services on a target router can be difficult without leaving logs and other traces on the network. However, there is a way to capture and view this Wi-Fi activity without ever connecting to the wireless network. So before you do that in your own network, I would suggest that you start with a sheet of paper and you can write down all your connected devices. That includes things like smart TVs, smart speakers, laptops, tablets, and phones, and any other device that might be connected to your network. Network administrators and engineers are very familiar with this step. It's the first step in exploring any network you're not familiar with. So please go ahead, do an inventory of the devices on your network, identify them, and then you can see if the reality matches to what you would expect. Your home network and everything connected to it is like a vault. Behind your login lies valuable information, from unencrypted files containing personal data to devices that can be hijacked and used for any purpose. In this video, I will show you how to take a peek under the covers and see who is talking to what, how to uncover devices or processes that may be sucking down bandwidth, or if there are unexpected guests connected to your network. So we are going to start firstly with setting our wireless network card to monitor mode. And then with the wireless network adapter in monitor mode, we can start listening on Wi-Fi traffic by running this command you see in front of you that we are going to type and explain in depth while we are doing that. So let's just go ahead and use the airmon ng command, and we're going to disable some processes before putting our interface into monitor mode. Let's just go ahead and kill all those processes. Now let's put the interface into monitor mode. So as you can see, our interface is on monitor mode. And you can see that the interface name have changed. So we are going to use that, start listening to Wi-Fi traffic. So let's write and explore the command that we have seen previously on the slides. So to view the Wi-Fi networks in the surrounding area, we can use the error dump ng command, start monitoring. We hit enter and we see the Wi-Fi network. So for using the error.ng command later on, to start capturing the Wi-Fi data that we want, we might want to take note of the MAC addresses, the PSSID of the target network, as long as the channel and the ESS ID, which is the name of the Wi-Fi. So for the purpose of this video, we are going to use this Wi-Fi name, the channel number 11, and we might want to take a note of this MAC address here. So now we are ready to start collecting data belonging to the target network. And we can just go ahead now and type the command that we saw earlier in these slides. So error dump -ng, we are going to use the MAC address, and we are before typing the MAC address, we are going to use the flag --BSSID space, and then we type the MAC address. As we said, we are going to be collecting data belonging on the VRV Wi-Fi. So let's just go ahead and type the MAC address of this network. Then space --ESSID then space the name of the Wi-Fi here, in this case VRV, then space dash C, and we're going to select the channel as we said earlier, which is number 11 in this case. Then we are going to use the flag dash W, and we are going to choose directory that we are going to save the collected data. So I'm going to use the TMP directory, and I am going to choose also like a name, like an example name that we are going to save the collected data. So just go ahead and type dash TMP. We are going to use the TMP directory, and then we are going to use a name for it. And then space, and don't forget to type the WLAN 0 mon. So there you go, you have it. So now you are ready to start. So now we are ready to start collecting all the data. So you can go ahead and hit enter. So as long as the Aerodub and Qi terminal is running, the data will continue to accumulate. This terminal, you can leave it and running for hours or even days. So as the command runs, you may want to pay attention on the data section. So for the purpose of this video, I am using my mobile phone, and I'm connected to the VRV wireless network, and I am going to go ahead and browse a little bit, and you can see how the data will start like counting more and more. You can see that this data column showcases how many data packets have been collected so far. The higher the number, the more likely it is to discover sensitive information which can be used to further compromise the target. So when a satisfactory amount of data have been collected, you can go ahead and stop the session by pressing Ctrl and C. So now there will be a file named cap-data.cap in the TMP directory. So this cap file later on can be opened using Wireshark. So as you saw, there was a lot of information in the cap file that we saved. And at first it might appear harmless, but as we will see in the next video and the later on videos, after inspecting such packet, you will be able to learn a lot of information about the target, and you can even reach to a point that you will learn personal information for the target. So as you saw, we haven't even connected to the router, and all of this data have been collected just by putting our network interface into monitor mode. There will be no way for victims to know this was happening to them. So all of this data can be used by attackers to launch an elaborate and targeted hack against companies and individuals. So tracking down Wi-Fi devices is easy with the right gear. Whenever a Wi-Fi network appears where it shouldn't, or a device starts connecting to your Wi-Fi without permission, many tools, including Wireshark, and of course having a network adapter, can tell you where the signal is coming from. This variable skill makes it easy to determine where a rogue access point might be hidden or who might be joining a network without permission. So for instance, if you suspect your neighbor's been connecting to your Wi-Fi network and you haven't been able to prove it, this technique could provide you with all the evidence that you need. So there is several ways you can keep your personal data safe from hackers, and some of those are listed on your screen right now in front of you. Be very aware of open and public Wi-Fis. Use secure browsers. Always use VPNs when you are using public Wi-Fis, and protect yourselves to the highest degree that you can. So I hope you enjoyed this video, and when you're ready, you can go ahead and click on the next video where you are going to learn how to decrypt the Wi-Fi traffic that you just captured.
Hello guys, and welcome to another video in this chapter. In this video we are going to learn how to decrypt previously captured Wi-Fi traffic with Wireshark. When you use a Wi-Fi network that uses WPA2 encryption, the security of your session is based on two things. The first is the password that you use to generate a much longer number, a PSK or pre-shared key. The second is the actual handshake itself, which has to happen to establish a connection. If an attacker has the PSK to the Wi-Fi network and either observes you join the network or kicks you off for a moment, they can decrypt your Wi-Fi traffic to see what you're doing. The content of HTTPS websites won't be able to be seen, but any plain HTTP websites you visit or any insecure HTTP requests apps on your phone make are in plain view. This may not seem like a big deal, but in only 60 seconds it's easy to learn a lot about the type of device we are monitoring and what exactly is running on it. Also, DNS requests to resolve the domains that apps need to talk to in order to work are easy to see, identifying which apps and services are active. So as discussed in the previous video, you will need a wireless network adapter card capable of wireless monitor mode in order to do this. Next, you will need an iOS or Android device connected to the Wi-Fi network that you are currently monitoring. You can also practice this on an open Wi-Fi network to see what you're supposed to see, as sometimes decryption may not work for the first time. You will also keep in mind that you will also need to know the password and network name of the Wi-Fi network you want to monitor. This will allow you to calculate the pre-shared key, allowing us to decrypt the traffic in real time. So let's just jump right into it and see how it is done in Wireshark. So once you open Wireshark and captured the desired Wi-Fi traffic, or in this case, as I did, I opened the previously captured Wi-Fi traffic by a device trying to log into the Wi-Fi network. So you can see that this is without decryption. We can only see MAC addresses of the data transfer participants, some types of packets. The payload is decrypted, and you can see no destination IP addresses. Everything is encrypted. So we can decrypt this conversation that we see in front of us, and in order to do so, we will need to add the Wi-Fi password in Wireshark. So in order to do that, you have to go to Edit, Preferences, and under Protocols in the pop-up window, you will have to go all the way down and search for IEEE 802.11. So remember that you need this to be enabled decryption, and you have to add the keys. So in the new pop-up window, you can see that you can select the key type, and also you can type the key. So for this session, we're going to add the Wi-Fi password, as we said, and after selecting from the drop-down menu, you can go ahead and in the key section area, you will type the password. And in this case, the password is induction. Press enter, and then okay. So once this is complete, you can see that Wireshark attempted to decrypt the packets. So now you can see that we are able to identify source IPs and destination IPs throughout all the Wi-Fi traffic capture that we have in front of us. So just like that, Wireshark makes Wi-Fi networks a very risky thing to trust. This kind of monitoring may seem invasive, but you should keep in mind that your internet service provider also keeps a log of this information and has the right to sell the information. If you want to prevent this kind of snooping, you should get a VPN that allows you to hide even local traffic behind strong encryption. In a place where you might be doing something sensitive over a data connection, you should also consider using cellular data. You should also consider using cellular data whenever possible to prevent this kind of attack. I hope you enjoyed this video to using Wireshark to spy on Wi-Fi traffic, and now you can go ahead and click on the next video where you're going to learn to sniff the activity over USB interfaces and how to do analysis in GUI.
Hello guys, and welcome to another video on this chapter. In this chapter, we are going to look into how you can sniff the activity over USB interfaces that are connected to your network. So when you install Wireshark, you are presented with a dialog asking if non-super users should be able to capture packets. Unfortunately, this only applies to the regular networking interfaces and doesn't apply to USB MON that we are going to use for this video. So you can verify if you're a member of the Wireshark group by using the ID command. In order for Wireshark to start seeing the USB interfaces and start capturing with Wireshark the activities that are going on these USBs, we need to adjust some things. So first of all, add yourself to the Wireshark group by running the command sudo add user $user Wireshark. You can see in front of you. And to dump USB traffic on Linux, you need the USB Mon kernel module. So if it's not loaded yet, please run this command as root modprobe USB mon. And you should also give regular users privileges and make the USB mon devices readable by typing the below command sudo setf acl and so on your terminal. So next step is to create a file. The next step is to create a file named 99-usbmon.rules in the directory provided in this slide at gudevrules.d, and you need to write the below The next step is you can use nano or v command to create the following file 99-usbmon.rules in the provided directory you can see. Inside this file that you will create, you will please paste the following allow members of the Wireshark group to access the usbmon commands you can see. Press Ctrl O if you're using nano, and please save the file and exit. Then run the command sudo udevadm control-reload-rules, and then you can run the command sudo udevadm trigger. This command causes the -dev usbmon files to have a group of Wireshark rather than a group of root. And if your user is a member of this Wireshark group, you will be able to access the dev usbmon files without being the root user. So next up, you need to use the command sudo modprobe usbmon to load the usbmon module. This is required to allow Wireshark to intercept USB traffic. You can verify that the permissions are correct, and you should see all the device nodes in the directory /dev/usbmon and have a group of Wireshark. So for this video, I prepared all these commands, and let's go and check if the permissions are correct. So you need to type ls space -l, then you provide the directory, so as you can see, all the usbmon devices they have the Wireshark group. So now we are ready. So once you plug in a USB device in your laptop or your computer, you need to determine which of the usbmon devices to use by looking at the output ls USB. This will provide a list of all the USB devices that are connected to your machine. So for the purpose of this video, I plugged in my mobile phone, which is a Samsung phone, and what you need to pay attention in order to determine which usbmon number you're going to use from these ones, usbmon 3 or 4, you need to take a look at the number provided in front of bus. So in this case, I plugged in, as I said, my phone, which is on bus 04. So in that case, we're going to use the dev/usbmon 4 for that purpose to check it out. Let's go ahead and use the command modprobe. usbmon, and then we can start Wireshark. So as you can see, we have all the USB interfaces here, and this is the USB interface that we want, as we said, usbmon 4. So now we can just go ahead and select usbmon and start capturing, and you can see that there will be data being recorded in Wireshark. So let's just go ahead and choose this, and you can see that the data will start being captured. So now, as you can see, there's nothing going on because my cell phone is idle. So as long as I will start using the cell phone and create folders or copy things, traffic will start coming here and will be captured by Wireshark. As you can see, I am in my phone right now, and I can just go ahead and create a new folder. So you can see there is traffic going on while I was creating that folder, and I can go ahead and delete the folder again, and you will see there is traffic going on again. So we can stop the capture now. And now that we have finished capturing the data and using our device, we can reduce the amount of data being presented. In this case, it wasn't so much data from our phone. So if you want, you can go ahead and use the filter that I'm going to type now in the display filter. USB.bus underscore ID equal sign, and then the ideas we said, we used the bus number 4 from USB Mon 4, so you're going to use 4. In your case, if your USB Mon is on 5 or 6 or 3, please replace it. Please replace the number accordingly, and then you can use USB.bus ID equal sign, and here you will place the number of the USB Mon device. So if you use USB Mon 4 like me, you need to put the number 4 on this bus ID. If you used 5 and 6 and so on, please replace the number accordingly. So I'm going to type 4 here, and then we can use the append sign, and then we can use the USB.device underscore address equal sign. So if we go back to our terminal, you can see that our mobile is, as we said, bus 04, and the device is 012. So in the USB device address, we are going to place the number 12. If your device is another number, please go ahead and replace accordingly. So here we are going to place number 12, pen sign, and finally we're going to use the filter USB cap data. So go ahead, you hit enter. So basically this filter is going to show us all the received and sent data. So you can go through each line and you can view all the information. So that was it for this video. I hope you get a very nice idea of how to intercept USB traffic. And now when you're ready, you can go ahead and click on the next video where you're going to learn how to use Wireshark to detect TCP delays.
Hello guys, and welcome to the last video for this chapter. In this video we are gonna go and look into the process of TCP delays and how you can spot some network delay, usually simply put as server or client latency. So I have fired up Wireshark here, and I have loaded a pre-captured network traffic that we are going to check for some TCP delays. What you might want to focus on while you are investigating network delays, such as server or client-side latency, is that which is you might want to use the view time display format second since previously displayed packet. So you might want, for me it's already selected here, so you might want to go and select that. So what this shows us is the time from the end of the first packet until the time of the end of the next packet. If you go down here to the transmission control protocol and expand it here, you might see, you will surely see the section stream index. So now you should know that Wireshark is numbering all the transactions that is happening in a network. So what I usually do is that this is a very useful column that you can apply. So just go ahead on the stream index and go to apply as a column. So you can see here it appeared, it's very close to info. So let's just go ahead on the column and align in the center, so we can have some space between the length and the info. So you can see the transactions are being numbered by Wireshark, if you can see here. And each transaction from one IP to another IP is being logged, numbered, as you can see. So the difference between the stream index and the time is that, as I said, the stream index, like when you are numbering it by stream index, so this will show us the time of the end of one packet to the time. So what the difference is between the stream index and time is that the time measurement here from the end of one packet to the end of another one, it can be the measurement of two different transactions. So thus it can be a little bit longer sometimes, although if you focus and you line up by stream index, you can see, let's say, the timings of the packet for this stream. Both are useful. It depends on what you are focusing on. So if you would like to see in general the delays on the network, and it doesn't matter to which transaction it's happening, so this is also useful. But if you would like to focus on a specific transaction that is happening between, let's say, two IP addresses, or between two ports of specific IP addresses, you might want to focus more on the stream index. Another useful filter you can use is if you go here again to TCP transmission control protocol area, you right click, you go to control preferences, and then calculate conversation timestamps. So once you press that, you will see that if you will go all the way down, there is a new section that appeared that is called timestamps. So let's just expand that. And then you have here in the drop-down menu and the time since previous frame in this TCP stream. So you can go ahead and right-click on time since previous frame in this TCP frame, and you can apply that as a column. So let's just shorten this out a little bit. Right-click and align it. What we have to say here is that there is some acceptable delays in general. So let's say, for example, you shouldn't focus on a huge gap between, let's say, the last received from the server for one client, which means probably they clicked on some link and now they're reading an article, so thus it will take a little bit more time for the user or client to click on the next link or move someplace elsewhere. So there can be some delays there that you might want to not focus. So now let's say that I would like to find the delays that happened in this network traffic that we captured that is more than 1 second. So the way to do that is you can go here, time since previous frame in this TCP stream. So right click, prepare a filter, and select it. So you can see that in the display filter there is a filter named tcp.time underscore delta equals some number. So we are going to take advantage of that and delete this one and the equal sign. And as we said, we would like to see the delay on the network which is greater. So we're going to use the greater sign than 1 second. So we can hit enter. And we can see all the traffic that is greater than 1 second. Here. So that was it for the last video of this chapter. I hope you enjoyed this chapter so far. And when you're ready, you can go ahead and click next to move on to the next chapter, chapter 3, where you're going to learn how to steal credentials and files from network streams.